Welcome to YQ Academy Core Java Interview Questions and Answers. 1. What are static blocks and static initializers in Java? Static blocks and static initializers are used to initialize static variables and perform any necessary setup tasks for a class. They are executed when the class is loaded into memory, before any instance of the class is created or any static methods are called. 1. Static blocks. Static blocks are enclosed within curly braces and start with the static keyword followed by the block code. They are executed only once when the class is loaded into memory, typically before the main method or any other static method is invoked. Static blocks are used to initialize static variables or perform any other one-time setup tasks. They can also be used for exception handling and other advanced initialization techniques. Static blocks cannot be called explicitly. They are automatically executed during class loading. 2. Static initializers. Static initializers are similar to static blocks but are written as static methods within the class. They are used to initialize static variables or perform any complex initialization tasks that require more than simple assignment statements. Static initializers can have parameters and return types, just like regular methods. They are called automatically during class loading or when the static variables they initialize are accessed for the first time. 2. How to call one constructor from the other constructor. In Java, you can call one constructor from another constructor within the same class using the this keyword. This process is known as constructor chaining. It allows you to reuse the initialization logic of one constructor in another constructor. In this example, the class myClass has two constructors, a default constructor and a parameterized constructor. The default constructor calls the parameterized constructor using this0, which initializes via LUE1 and via LUE2 with default values of 0. By chaining the constructors, you can avoid duplicating code and ensure consistent initialization of instance variables. 3. What is method overriding in Java? Method overriding in Java is a feature that allows a subclass to provide a different implementation of a method that is already defined in its superclass. In other words, when a subclass defines a method with the same name, return type, and parameters as a method in its superclass, it is said to be overriding the superclass method. In this example, the animal class has a method called makeSound. The cat class extends animal and overrides the makeSound method with its own implementation. The main class demonstrates the use of method overriding, where different objects of animal and cat classes invoke the makeSound method. The method call is resolved at runtime based on the actual type of the object, showcasing polymorphism. 4. What is method overloading in Java? Method overloading in Java is a feature that allows multiple methods with the same name but different parameter lists to coexist within the same class. It provides a way to define methods with similar functionality but different input parameters, allowing developers to create more intuitive and flexible code. In this example, the calculator class has 3 overloaded add methods. Each method performs addition but accepts different types and numbers of arguments. The first method adds 2 integers, the second method adds 2 doubles, and the third method adds 3 integers. During method invocation, the appropriate method is determined based on the arguments passed. The Java compiler resolves the method call at compile time. In the main method, we call each overloaded add method with different arguments, and the corresponding method is invoked based on the provided arguments. Method overloading provides flexibility and convenience by allowing the use of the same method name for similar operations, but with different parameter types or quantities. 5. Difference between method overloading and method overriding in Java. Method overloading occurs within a single class. Method overriding occurs between a superclass and its subclass. Method overloading allows multiple methods with the same name but different parameters to exist in the same class. Method overriding involves redefining a method in the subclass that is already defined in the superclass. The overloaded methods must have the same name but different parameter lists, number, type, or order of parameters. The overridden method must have the same name, return type, and parameters in both the superclass and subclass. The return type can be the same or different. The access modifier of the overridden method in the subclass cannot be more restrictive than the access modifier in the superclass. The method is chosen for execution based on the arguments passed at compile time static polymorphism. The method is chosen for execution based on the actual object at runtime dynamic polymorphism. Overloading is determined at compile time. Overriding is determined at runtime. 6. What is super keyword in Java? In Java, the super keyword is used to refer to the superclass or parent class of a subclass. It can be used to access the members' variables, methods, constructors of the superclass and invoke them from the subclass. In this example, the dog class extends the animal class. The dog class has its own color variable and a display method. Inside the display method, color refers to the color variable of the subclass dog, while super.color refers to the color variable of the superclass animal. Similarly, super.eat opening bracket closing bracket is used to invoke the eat method of the superclass. 7. Why is Java platform independent? 1. Java Virtual Machine JVM. Java programs are compiled into bytecode, which is a platform-independent representation of the code. The bytecode is then executed by the Java Virtual Machine JVM installed on the target platform. The JVM acts as an interpreter and translates the bytecode into machine code that is specific to the underlying operating system and hardware. 2. Bytecode interpretation. Java programs are not directly executed by the operating system or hardware. Instead, the JVM interprets the bytecode and translates it into machine code at runtime. This interpretation step allows the JVM to adapt the execution to the specific platform, making Java programs portable across different operating systems and hardware architectures. 3. Platform-specific implementations. The JVM has platform-specific implementations for different operating systems and hardware. These implementations ensure that the JVM can run on various platforms, providing a consistent runtime environment for Java programs. The JVM abstracts away the low-level details of the underlying platform, allowing Java programs to run consistently across different systems. 4. Standard APIs and libraries. Java provides a rich set of standard APIs, application programming interface, and libraries that abstract away platform-specific functionalities. These APIs provide a consistent interface to perform various operations, such as file handling, networking, and user interface interactions, regardless of the underlying platform. By relying on these standard APIs, Java programs can maintain their functionality across different platforms without needing to rewrite platform-specific code. 5. Security and sandboxing. Java incorporates strong security features, such as bytecode verification and runtime sandboxing. The JVM enforces strict security checks on the bytecode, ensuring that it does not violate any security constraints. This security model adds another layer of platform independence, as Java programs can run securely within a controlled environment on different platforms.